today we are going to work on determinants. Okay, we are determined to find determinants today. True. Okay. So every square matrix, remember I keep talking about how square matrices are special. Here's another special thing we can do with a square matrix. Okay, so every square matrix is associated with a number called its determinant. And determinants have some special notation. Okay. So if we're talking about matrix A, if we want to find its determinant, you're going to see this right here. You're going to see like the absolute value bars. Okay? So when the absolute value bars are used in relationship to a matrix, that means the determinant. Okay? So I am going to show you how to find a 2 by 2 determinant and a 3 by 3 determinant. We can find determinants for any square matrix, but we're really going to just focus on 2 by 2s and 3 by 3s. Okay. So, what happened? Okay. So here's how we find the determinant of a 2 by 2 matrix. Okay. So here is our matrix. Okay. The determinant, which we notate, this is how, like, you're going to see it in your calculator, DET. This is how you're probably going to see it in your book, that absolute value sign. To find a 2 by 2 matrix or 2 by 2 determinant, we're going to take A1 times B2 minus A2 times B1. Well, that's familiar, isn't it? Have we seen that before? We've seen it with inverses, right? This is our 1 over Chris minus cross, isn't it? Okay. Here's Chris minus cross. That's how we find a 2 by 2 determinant. And that's, oddly enough, something that we use when we find the inverse. Ready to practice? Okay, so first of all, I want you to notice how in this matrix, I don't have the brackets, I have just the up and down bars. Okay, when that happens, what does that mean? We're finding the determinant. So sometimes we'll be giving a matrix. If it's just the absolute value bars instead of the brackets, that means find the determinant. Okay, how do we find this determinant? Help me out. Okay, Chris minus cross. So we have 2 times 2 minus 1 times negative 3. So what is our determinant?
7.
Done. Right, that's it.
Sometimes it can be as easy as
Write this one down. 2142. Yes, and we're going to talk about what it means. Okay. So how do we find the determinant? Okay, Chris minus cross. So our determinant is 0. Michaela said, can it be 0? The determinant can be 0, but what do we use that number for? This is the number that we do what with in the inverse? Okay, 1 over this number times our switching and negating, right? So if my determinant is 0, what is that telling us? What would be a sign? Okay, so if our determinant is 0, this means that the inverse doesn't exist. Okay. If we get a determinant to be 0, the inverse doesn't exist. Okay, because we know that when we find a 2 by 2 matrix, we take 1 over that number as our scalar, and we can't divide by 0. What's cool about this, it's going to be true for no matter what size. No matter what size it is, if we get our determinant to be 0, the inverse is not going to exist. Okay, so if we get a 3 by 3 determinant to be 0, we know the inverse isn't going to exist. Okay, so the determinant can sometimes tell us something about our matrix. Okay. Let's work on, this problem first. Okay, write it down. Okay, so first of all, I want you to notice that you do not see brackets. You see those straight up and down lines, which means on the left side we need to compute the determinant. Okay, how do we do that? Okay, so Chris minus Ross. And we know that the determinant must equal 0. What do we have to do to solve this problem? It is a quadratic. Okay, what should we do before we factor? Okay, we need to multiply all this out so we can see what trinomial we have. So when we multiply x plus 4 times x minus 5, what do we get? X squared minus x minus 20, and then we're subtracting a negative 14, which is the same thing as adding 14. And so our trinomial is x squared minus x minus 6 equals 0. So now we have a quadratic that equals 0. We can factor. What can we factor to? So that means x is? Are we allowed to have negative numbers in our matrices?
Yes.
Yeah. Both of those answers are great. Okay. Those are just values that work for x. So when we plug those in, we would have two different matrices that have determinants of 0. Okay. You're going to have problems like this on your homework. You're going to have a problem like that again later this week. Do not skip them in your homework. Okay? Okay. Okay. Here we're going to work on determinants of larger than 2 by 2. Okay? Really, we're only going to focus on 3 by 3 matrices, but this is a process that can be done for any square matrix. Okay? So we're going to go through the steps and kind of write it out all at once. Now, I want to just warn you, your book is going to talk about a few different methods. We're not going to worry about the methods that they talk about. There's like a cofactors method. I don't really want to worry about that. I just want to do it this way. Okay. So in the instructions in your book, in your homework, if it ever says something funny like use the cofactors or use this, ignore the method that they're wanting you to use. Any 3x3 matrix determinant, I want you to use this way, no matter what the book is asking. Okay? So, the first thing you're going to do, okay, so first thing I want you to do is copy down this matrix. It's a 3x3 matrix. A, B, C, D, E, F, G, H, I. Okay? And then you're going to write the steps with me. Okay? So copy down that matrix and leave some room. Okay? Leave some room because we're going to do some work right there with that matrix. So maybe don't write anything to the right of it. Maybe like skip a line and start writing your steps. Okay? So the first step, copy all but the right column on the right side of the matrix. Copy all but the right column on the right side of the matrix. So, everything but the right column would be our first column and our second column. Then it says multiply down diagonals, multiply up diagonals, and we're going to take the sum of the down minus the sum of the up. Go ahead and just write that, and then we'll do all of that together at once. Okay, maybe you're already ahead of me. Maybe you've already written that down. So we're gonna, it's essentially the same kind of process where, we did that Chris minus cross, okay? We're just gonna have to do multiple diagonals now, okay? So we're gonna take all of the down diagonals, all of the up diagonals, and then subtract them. So first let's work on the down diagonals, okay? So we're gonna put all of the down diagonals in parentheses. So you're gonna start in the very top left corner and you're gonna multiply A times E times I. And then you're gonna add the next diagonal, B times F times G. And then you're gonna add the next diagonal, C times D times H. Okay? We're working with a 3x3. I no longer have a diagonal with 3 numbers, so those are my up diagonals. Okay. Now we're going to take those are our down diagonals. I said that wrong. Sorry, those are our down diagonals. Now we're going to subtract the sum of our up diagonals. Okay, so you're going to start in the bottom left corner now and work your way up. So G times E times C. You're going to add that to H times F times A. And you're going to add that to I times D times B. So you're going to take all of your down diagonals minus all of your up diagonals. So it's still kind of the same process of criss minus cross. You just have a few more multiplications to worry about. Okay? This is something that I really encourage you to show your work for. Okay? Those of you who took the quiz yesterday, more than likely you made a silly little mistake where you multiplied two numbers incorrectly. Did it happen? You missed a negative. You did something silly, right? The same can be true about these problems. Okay, we have 1, 2, 3, 4, 5, 6 different products to take. Okay, show me each of these products. That way, if you get your determinant wrong, we can at least figure out what the problem is. Okay, so let's try this one out. Write it down. What's our first step? Okay, so copy down everything but the last column. So 3, 3, negative 1, 4, 5, 4. Okay, then essentially we're going to do criss minus cross. We're going to work on all the down diagonals. So we have 3 times 5 times 1. 15. Plus 4 times 0 times negative 1. 0. Plus negative 2 times 3 times 4. Negative 24. Okay, those are all of our down diagonals. Now we're going to subtract all of our up diagonals. All right, so bottom left corner, negative 1 times 5 times negative 2. Plus 4 times 0 times 3. 0 plus 1 times 3 times 4. Okay. What's 15 minus 24? And what is 10 plus 0 plus 12? So what we have is negative 9 minus 22. So the determinant is negative 31. It is okay for the determinant to be negative. It is okay. Get out your calculator. Okay. Now, I promise you that you will have 2x2 and 3x3 matrices on your test, and your test is going to be all non-calculator. Okay? But we can do determinants in our calculator. All right, so I'm going to teach you to do that. I want everybody to put that 3x3 matrix in matrix A. What's our matrix?
3, 4, negative 2, 3, 5, 0, negative 1, 4, 1.
Okay, this is what you're going to do. You're going to go back to the home screen. And in your matrix menu, under math, you should have, your first option is DET. That's determinant. And then you can call up your matrix A. Don't you? Don't you love it? It's great.
Why do you want to do it? Just use the calculator.
What?
Why do you want to do it by hand? Just use the calculator.
We need to do by hand. Okay. So, you have some time to practice these by hand. Now, there will be a few of these that say, use your graphing utility to find the determinant, but only use your graphing utility when it asks you to use your graphing utility, because you will have to do these by hand on Friday.